Great, thank you very much. I had a different approach. I have a very, very narrow technical problem that I just wanted to solve, which is how to store very simple ML output, simple classification tasks in a standards-based format in a way that we could use for, we could store archivally at the hospital, and we could sort of try to force vendors to sort of standardize on a single output. And right now we have a bunch of, at my hospital, a bunch of proprietary formats. Things are hidden in private tags, they're in JSON, and 5 years from now, who will be able to read any of this stuff? So we want a structured format, and there's one that's currently supported by our clinical systems, which is the Highdicom basic diagnostic imaging report, or Highdicom, basic text as a structured report. And that seems to be compatible with a bunch of the backend systems, but creating Highdicom is really painful. And so what we needed was a clean way. If we're going to tell people you need to create this format, we wanted to make it easy for that to happen. So there's an existing Python library, which I would encourage you all to look at. There's an archive paper on it. I should have put that on here as well, called Highdicom, which supports Highdicom segmentation objects, Highdicom enhanced SR, comprehensive SR, but it doesn't support the basic text one, the very simple one. But what this does provide, the simple one, is it's a mechanism for storing coded results. So you can have SNOMED code, CDE codes, LOINC, whatever you want. But you can send the objects in standard Highdicom to a Highdicom server. And what we wanted to here was build a clean way to create this Highdicom for ML people around the hospital and for vendors. So the scope of the hackathon work was I was going to add the basic text SR class to Highdicom, that this is, again, it's only used for simple classification algorithms or simple measurement algorithms, like what the bone age of a child is, or a certain very simple measurement. If you want more complicated things, you go to comprehensive or enhanced SR. But I wanted to create something simple here, create some unit tests, and then test it with 3 different tools that I have. There's a structured report browser by the author of the Highdicom SR protocol. Osirix is a workstation that has an FDA-approved Highdicom viewer, and it does a medium job of displaying SRs. And then there's also a validator. So here is what the output looks like that I created. So I created the library, and you can see that the top part, the first finding is that there's a code for headache, and I'll show you the SNOMED code for that in a moment, because I always get a headache when I have to read the Highdicom standard closely. And then below that, I just had a bunch of text. It's free text, but basically we need, at least I need to store clinical ML output on clinical systems. And here's a very simple way to do it. And so I put it together, it works. There's a little bit more work needed to complete the library. There's an observation class that needs to be added. There's some measurement things that need to be added, but the basic structure of it works. It's displaying in this tool. In Osirix, also the output comes out here just fine. And it's Highdicom SR is not a presentation format, so that it's somewhat ugly, but it displays. This is what the SNOMED code looks like. And for those of you who aren't familiar with it, if you have coded output like this, for the results, it's much easier to scan through the output and say like, oh, this person had a headache. I forget how many SNOMED codes, 30,000 was the last time I checked, but it's probably more now. But this would mean that you don't have to sort of do NLP through reports to extract this information back out to find out if your algorithm was accepted, or it just removes ambiguity in the system to use codes where you can. And so the next steps are I'll finish up the coding. I've pushed it out to my private GitHub thing, but I'll put in a merge request in a day or so to go into Highdicom. I'm going to test the output on some existing ML models that I have at the hospital to see how well it works. And then the big challenge is how to get this to work in a clinical workflow. One of the nice things about SR, though clinical systems that I work with don't do this yet, is that you can, if you have the original ML result, you can create a new structured report object that points back to the original, where you accept or reject the findings of the model. And so you can build basically a tree of these things or a GAG of these things. But none of the clinical systems I know support that, but I think we're going to need something like that in the near future, because it's so much, as we want to scale up the number of models coming in, we want to standardize the format things are saved in, and then we want to build usable workflows around that with the clinicians. And so that's it.